When adding receptacles to finished walls, especially in a new commercial space, there are several alternatives to consider besides using old workboxes. Firstly, let's explore some of these box installation methods. Cut-in outlet boxes involve cutting a hole in the drywall and installing a box that fits directly into the opening. This method provides a clean and flush finish but does require cutting into the finished drywall. Secondly, surface-mounted boxes can be installed on top of the drywall using screws or adhesive. This approach is less invasive but might be less aesthetically pleasing. Thirdly, poke-through boxes, similar to surface-mounted boxes, are installed by punching a hole through the drywall and inserting a pre-assembled box. These offer a semi-concealed solution. The best method for installing electrical boxes into pre-existing structures really depends on the specific circumstances of the installation site. It's worth considering the trade-offs of each installation method, and for example, with cut-in electrical boxes, you need to first accurately mark the desired location for the electrical box on the wall. Use a level to ensure that the marks are plumb and square, then carefully cut an opening in the drywall using a drywall saw or a utility knife. Make sure the opening is sized correctly for the cut-in box you will be using. Next, insert the cut-in box into the opening, making sure it fits snugly and flush against the drywall surface. Secure the box in place by tightening the screws or clamps on the side of the box. These will grip the back of the drywall and hold the box securely in position. Before wiring the receptacle, ensure that the power is turned off to the circuit you will be working on. Strip the insulation from the ends of the wires and connect them to the appropriate terminals on the receptacle. Typically, the black wire goes to the brass screw, the white wire goes to the silver screw, and the ground wire goes to the green screw. Carefully push the wires back into the electrical box and secure the receptacle in place with screws. Ensure that the receptacle is flush with the wall surface and properly aligned. Once the receptacle is installed, test it with a circuit tester to ensure that it is wired correctly and functioning properly. This will help prevent electrical hazards and ensure the safety of the installation. It is essential to adhere to local electrical codes and regulations when installing electrical boxes and receptacles. These codes provide guidelines for safe wiring practices and material usage, helping to prevent electrical fires and other hazards. If you are unsure about any aspect of the installation process, consult with a qualified electrician for assistance. They can provide guidance and ensure that the work is completed safely and correctly. Using surface-mounted electrical boxes involves several key steps to ensure a safe and effective installation. Firstly, determine the desired location for the electrical box on the wall or ceiling. Use a level to ensure that the marks are plumb and square, then mark the mounting holes on the surface. Next, pre-drill pilot holes at the marked locations to make it easier to drive in the screws. Choose drill bits that are slightly smaller than the diameter of the screws to ensure a snug fit. Position the surface-mounted electrical box over the pilot holes and align it properly. Insert screws through the mounting holes of the box and into the pilot holes in the wall or ceiling. Tighten the screws until the box is securely attached to the surface. Avoid over-tightening, which can damage the box or the surrounding material. Before wiring the receptacle or switch, ensure that the power is turned off to the circuit you will be working on. Use a circuit tester to verify that the power is off before proceeding. Strip the insulation from the ends of the wires and connect them to the appropriate terminals on the receptacle or switch. Typically, the black wire goes to the brass screw, the white wire goes to the silver screw, and the ground wire goes to the green screw. Carefully push the wires back into the electrical box and secure the receptacle or switch in place with screws. Ensure that the device is flush with the box and properly aligned. Once the receptacle or switch is installed, test it with a circuit tester to ensure that it is wired correctly and functioning properly. This will help prevent electrical hazards and ensure the safety of the installation. Remember to seal any gaps or openings around the edges of the surface-mounted electrical box with caulk or sealant to prevent moisture or air from entering. This will help protect the electrical connections and prevent corrosion. Poke-through electrical boxes offer a convenient solution for adding electrical outlets or data connections to existing walls or floors. Installing poke-through electrical boxes involves several key steps to ensure a safe and reliable installation. Firstly, determine the desired location for the poke-through electrical box on the wall or floor. Use a stud finder to locate any studs or joists behind the surface and ensure that the location is free from obstructions. Next, use a hole saw to cut a hole through the wall or floor at the marked location. Choose a hole saw that matches the diameter of the poke-through electrical box to ensure a snug fit. Insert the poke-through electrical box into the hole, making sure it is oriented correctly and flush with the surface. Secure the box in place by tightening the screws or clamps in the side of the box. These will grip the back of the wall or floor and hold the box securely in position. Before wiring the receptacle or data connection, ensure that the power is turned off to the circuit you will be working on. Use a circuit tester to verify that the power is off before proceeding. Strip the insulation from the ends of the wires and connect them to the appropriate terminals on the receptacle or data connection. Typically, the black wire goes to the brass screw, the white wire goes to the silver screw, and the ground wire goes to the green screw. Carefully push the wires back into the electrical box and secure the receptacle or data connection in place with screws. Ensure that the device is flush with the box and properly aligned. Once the receptacle or data connection is installed, test it with a circuit tester to ensure that it is wired correctly and functioning properly. This will help prevent electrical hazards and ensure the safety of the installation. Remember to seal any gaps or openings around the edges of the poke-through electrical box with caulk or sealant to prevent moisture or air from entering. This will help protect the electrical connections and prevent corrosion. Regarding MC cable pricing, the cost varies depending on the size and type. As a general estimate, a 250-foot roll of 12 American wire gauge MC cable might range from $120 to $180. Always check with local suppliers for current pricing. Besides the cost of MC cable, you'll need to also consider the cost of fittings, connectors, and other necessary hardware for the installation. These additional expenses can add up, so it's important to factor them into your budget. When working with electrical systems, safety should always be your top priority. Wear appropriate personal protective equipment such as gloves and safety glasses to prevent injury. Follow all electrical codes and regulations to ensure that the installation is safe and compliant. If you're not comfortable working with electricity, it's always best to hire a qualified electrician to do the job. They have the knowledge and experience to handle electrical work safely and effectively. In addition to the technical aspects of the installation, it's also important to consider the aesthetic appearance of the finished product. Choose electrical boxes and wiring methods that blend in with the surrounding environment and minimize visual clutter. Consider using wire management techniques such as cable ties or raceways to keep the wiring neat and organized. Additional considerations are present when working on electrical installations, such as 12-foot ceilings, requiring you to use a CISO lift or genie lift to reach them safely and efficiently. Starting an electrical contracting business means remembering to factor in the cost of ladders, supplies, and other expenses. Given the challenges of installing old work boxes in a new building, cut-in outlet boxes are recommended. This method provides a more professional and durable solution that minimizes the damage to the finished drywall. When working on electrical projects, it's essential to follow all relevant safety guidelines and regulations to prevent accidents and injuries. Always turn off the power to the circuit you're working on before starting any electrical work. Use a circuit tester to verify that the power is off before proceeding. Wear appropriate personal protective equipment such as gloves and safety glasses to protect yourself from electrical hazards. Avoid working in wet or damp conditions, as water can conduct electricity and increase the risk of electric shock. If you're not comfortable working with electricity, it's always best to hire a qualified electrician to do the job. They have the knowledge and experience to handle electrical work safely and effectively. When selecting electrical boxes and wiring methods, consider the specific requirements of the project and choose options that are appropriate for the application. For example, if you're installing electrical boxes in a damp or wet location, use weatherproof boxes and fittings to protect the electrical connections from moisture. If you're running wiring through walls or ceilings, Use appropriate cable supports and fasteners to secure the wiring and prevent it from sagging or becoming damaged. Consider the long-term maintenance and accessibility of the electrical system when planning the installation. Choose locations for electrical boxes and wiring that are easily accessible for future maintenance and repairs. Label all electrical boxes and circuits clearly to make it easier to identify and troubleshoot problems in the future. Finally, document the electrical installation thoroughly, including wiring diagrams, circuit schedules, and equipment specifications. This documentation will be invaluable for future maintenance and repairs and can help ensure the safety and reliability of the electrical system. When installing electrical boxes and wiring, it's important to follow best practices to ensure a safe and reliable electrical system. Use proper wiring techniques such as making secure connections and avoiding sharp bends in the wiring. Protect the wiring from physical damage by using conduit or other protective measures in areas where it may be exposed to impact or abrasion. Avoid overloading electrical circuits by distributing the electrical load evenly across multiple circuits. Use appropriately sized wiring and overcurrent protection devices such as circuit breakers to prevent overheating and electrical fires. Test the electrical system thoroughly after installation to ensure that it is functioning properly and safely. Use a circuit tester to verify that all outlets and switches are wired correctly and that the grounding system is properly installed. Finally, provide clear and concise instructions to the building owner or occupants on how to operate and maintain the electrical system safely. This includes information on how to reset circuit breakers, how to replace light bulbs, and how to identify and report any electrical problems. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable working with electricity, hire a qualified electrician to do the job. They have the training, experience, and equipment necessary to handle electrical work safely and effectively. By following these guidelines and best practices, you can help ensure a safe, reliable, and efficient electrical system for your home or business. Remember to always prioritize safety and consult with qualified professionals when necessary. When selecting electrical boxes for a project, consider the material they are made from and the environment in which they will be installed. Metal electrical boxes are durable and provide good protection for wiring, but they can be susceptible to corrosion in damp or wet environments. Non-metallic electrical boxes are resistant to corrosion and are suitable for use in damp or wet locations, but they may not be as strong as metal boxes. Choose electrical boxes that are appropriately rated for the environment in which they will be installed, such as weatherproof boxes for outdoor applications or fire-rated boxes for fire-resistant walls and ceilings. When running wiring through walls and ceilings, use appropriate cable supports and fasteners to secure the wiring and prevent it from sagging or becoming damaged. Use cable staples or cable ties to secure the wiring to studs, joists, or other structural members. Avoid running wiring through areas where it may be exposed to physical damage or abrasion, such as through sharp edges or in areas where it may be stepped on. Use conduit or other protective measures to protect the wiring in these areas. When making electrical connections, use proper wiring techniques to ensure secure and reliable connections. Use wire connectors such as wire nuts or terminal blocks to join wires together. Make sure the wire connectors are properly sized for the wires being joined and that they are securely tightened. Avoid using tape alone to join wires together, as tape can dry out and become ineffective over time. When installing receptacles and switches, use appropriate wiring methods to ensure that they are properly grounded. Connect the grounding wire to the grounding terminal on the receptacle or switch and to the grounding system of the building. This will help protect against electric shock and prevent damage to electronic equipment. When working with electrical circuits, it's important to understand the basics of electricity and how electrical circuits work. Electricity flows from a source of voltage, such as a battery or power outlet, through a conductor, such as a wire, to a load, such as a light bulb or an appliance. The load consumes the electrical energy and converts it into another form of energy, such as light or heat. The electrical circuit must be complete for electricity to flow. If the circuit is broken, the electricity will not flow and the load will not operate. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the rated capacity of the circuit breaker or fuse, the device will trip or blow, interrupting the flow of electricity and preventing damage to the electrical system. It's important to use appropriately sized overcurrent protection devices to protect electrical circuits from damage. Do not use oversized circuit breakers or fuses, as they may not provide adequate protection. Also consider the type of wiring used and the ampacity, making sure you are using the appropriate gauge. Remember to check the National Electrical Code or the local electrical code when doing electrical installations, modifications or upgrades.